Hello, this is the first video that I made for differential equation tutorials. So we're gonna look at this particular differential equation, a very generic one. It's a second order linear differential equation with constant coefficients. So A, B, C are constants. So if you look at this and how we're gonna solve this, but in this case we're gonna assume for this particular case that the discriminant of the systems, which is b squared minus 4ac equal to 0. So what do we expect from this? We're gonna expect the result with double root, basically. So the first thing that we need to find is that we want to find the root of the characteristic equation. We have to come up with characteristic equation. So we set our y, we say that assume that y equal to e to the rt, or y is in form of e to the rt. Right, it's one of the solution. And you basically differentiate this. And this is important that you have to say that r here is a constant, right? If rt is a constant, then you can do this derivative here. Once we get these three terms here, you just simply substitute to the original equation. So we have a multiplied by r squared e to the rt plus b r e to the rt plus c e to the rt. The entire thing have to equal to 0 because you have to satisfy this equation here. And you know that e to the rt cancel out. We will get a r squared plus br plus c equal to 0. Now, from differential equation that we have, we can derive this characteristic or just simple quadratic equation. We know the formula is r equal to negative b plus or minus square root of b squared minus 4ac, and entire thing divided by 2a. So you know that there is three possibility. When this b squared minus 4ac is positive, then you have two real roots. When it's 0, you have one double root, and another one is when this entire thing here, because b squared minus 4ac is negative, then we have the complex root. But in this case, we're gonna assume that b squared minus 4ac is 0. So the only r that you're gonna have is negative b over 2a. So people ask me for why the solution is gonna be written in terms of y equal to c1 e to the rt plus c2 t e to the rt. Where do you get this t from? And this video I'm going to explain that. So let's say we assume that y2 here is going to be written in terms of some function y that depends on time multiplied by y1 itself, or I can write into just y vy1, right? And all you have to do is substitute this y2 back to the original equation and to solve for v in this case. So what's the original equation? It's a y double prime plus by prime plus cy equal to 0. So this is how we're gonna do it. A, right? So y2 double prime is just y vy1 double prime plus b vy1 prime plus c vy1, and entire thing you have to equal to 0. Now you substitute everything, you will have let's start with this one, which is the easy one, and then you have to use product rule because v depends on time and y1 depends on time, and we take differentiate respect to time here. So we have v prime y1 plus v y1 prime. Well, that's not bad. So now we have to differentiate this term. So we just differentiate once, we have to differentiate again. So we're just gonna differentiate this term here. So we have y1 v double prime y1 plus v prime y1 prime plus v prime y1 prime. So we have 2 v prime y1 prime plus v y1 double prime, right? If you notice here, this term here, a y1 prime, b y1 prime, and c y1, that entire thing add up to 0. So if I distribute it correctly, so I have this plus 2v y1 prime plus a v y1 prime, and then I have this term b v y1 prime, and have this term b c y1 plus, I forgot this term here, b v prime y1. Right? So I didn't do anything at all, I just moved things around. The entire thing have to equal to 0. Right? And if you notice that a y1 double prime plus b y1 prime plus v1, so basically I can take the v out, and I get this entire equation here. But entire equation, we've been told in the beginning that this have to equal to 0 here. So if that's the case, then the entire thing here go to 0, right? Which leave us with v double prime y1 plus 2v prime y1 prime plus b v prime y1. That's equal to 0. So if you solve entire thing out, I can divide entire equation by a, and I will have b double prime y1 plus 2 v1 y1 v prime y prime plus b over a v prime y1 equal to 0, and I just combine these two terms together because they both have v prime. So we have that's multiplied by v prime. Okay. So now we have the entire equation written in this form. Now we want to do reduction of orders in order to see what is going to be our v. So you notice that we don't have one v at all. We have v prime and we have v double prime. So the v term is gone. And how can you come up with the way to do this? So we're going to assume that w is equal to v prime, and w prime is equal to v double prime, and then we're just gonna substitute, solve for w, and then we go back and solve for v. And let's see in the next video how we're gonna do this.